Hello, this is our video presentation for Mathematics PBL. Our group consists of Farah, Irshad, Kahirul, Fatin, Omeril, and Stephanie.
As an introduction, descriptive statistics are figures that are used to summarize or otherwise characterize a set of data. Informative statistics or figures provide a useful and sensible description of a report and its findings. Descriptive processing is commonly used to classify a demographic segment and aids in the analysis of vast amounts of data. Each meaning condenses a long list of definitions into a concise overview. The mean, median, and even mode are three significant features. The average is calculated by multiplying the cumulative numbers by the main data numbers. The mean is often used to measure the data set score. The median is a way of determining the center of a metric collection, and the data must be sorted in ascending order. Statistical dispersion is a concept that can be used to describe how a set of data is distributed. The data distribution can be defined using a set of descriptive statistics such as variances, standard deviation, and interquartile range. The data distribution is represented by dot, box, stem, and leaf tracks.
The problem we chose is problem 2. This problem states that we are employed as a statistician for a company that makes household products, which are sold by part-time salespersons A, B, C, and D. Table 16 shows the sales record for the 4 salespersons for 6 weeks. These are the equations we will be using for this problem.
Okay, hi and Assalamualaikum. So me as a salesman A will talk about the mean, standard deviation and coefficient of variation of A. So firstly, the total of frequency we get is 10,985. Next, for the power of 2 of frequency we get 20,140,765. So moving on to our mean. To get the value of mean, 10,985 as the total of frequency will be divided by 6, which is the number of the data, and we will get the answer is 1,830.83. Next, for our standard deviation, 20,140,765 we minus with 10,985 with power of 2, and after that we divide by 6, and the value will be divided again with 6 minus 1, and after that we square root all the answer to get the final answer, which is 76.24. And lastly, for our coefficient of variation, need to divide the standard deviation with the total value of the frequency and multiply with 100%. So 76.24 we divide by 1,830.83 and we multiply with 100%, and we will get the final answer is 4.16%.
Now, moving on to salesman B. Table 18 shows the data of salesman B that are needed to calculate the mean, standard deviation, and the coefficient of variation. The sum of x is 11,685, while x squared rounds up to 23,292,303. By applying their respective formulas, we can obtain a mean of 1,947.5, a standard deviation of 327.34, and the coefficient of variation being 16.81%.
For my part, I will explain the data of salesman C and its calculation to find the mean, standard deviation, and coefficient of variation. From the table, the total amount of data is 7,861. Then each data is powered by 2 and sum up to find the total amount of x squared. To find the mean, we using the equation mean equal to total amount of data divided by number of data. After entering the data, the value of mean that we get is 1,310.167. For the standard deviation, we get 149.48. For the coefficient of variation, the value that we get is 11.41%.
Next is Salesman D. The table shows the data of Salesman D that are needed to calculate the mean, standard deviation, and the coefficient of variation. The mean of Salesman D is 1604, and for standard deviation is 165.06, and lastly is the coefficient of variation, which is 10.29%.
Table 21 show the summary of data of each salesperson that consists of mean or average sale, standard deviation, and coefficient of variation. Based on table 21, it is shown that salesperson B has the highest mean, which is 1947.5 compared to the other salesperson. Higher means correspond to higher average volume of sale. Hence, salesperson B made the highest volume of sale among all. Besides, salesperson A has a smaller value of standard deviation than the others, which is 76.24. This means that the value of sales of salesperson A for each week is close to the average value. Then the salesperson B has the highest standard deviation value, which is 327.34. This means that the number of sales is more spread out.
In the coefficient of variation, salesperson A has a lower coefficient than the other, which is 4.16%, while the highest coefficient is salesperson B, which is 16.81%. The coefficient of variation is the ratio of standard deviation to the mean. The lower the value of the coefficient of variation, the more precise the estimate, while the higher the coefficient of variation, the greater the level of dispersion around the mean. So, from the data, the sales of salesperson A are almost the same for each week. Thus, salesperson A has the most stable money.
As a conclusion, a method of summarizing or characterizing a collection of data is known as descriptive data. Actually, the purpose of descriptive data is to make it easier for people to interpret data, particularly when the data is big. Despite these drawbacks, descriptive statistics offer a useful description that can be used to compare individuals or other units. The main goal of descriptive statistics is to provide a quick overview of the samples and measurements used in a report. All should learn how to use descriptive data because it is extremely useful in our daily lives. This approach will be used in a variety of fields, including research, education, industry, engineering, medicine, economics, and social planning. But sometimes this descriptive data cannot be used because it is limited in so much that they only allow you to make summations about the people or objects that you have actually measured. It cannot be used when we have collected to generalize to other objects or people.
Lastly, we would like to thank Madam Hazika for her contribution and attention in the making of this PBL. That's it from us. Thank you.